Hello, I am Dominique Archambault, professor at University Paris 8. In this short animation, we will try to understand the principles of software accessibility and see who is involved and at what level. 2 tips. The animation shows better when displayed in full screen, and don't hesitate to use the pause button. Oh, last thing before we start. This is of course a simplification. Things are a bit more complicated inside a computer. The goal here is not to explain in detail how assistive technologies work, but to understand the principle and what is needed for accessibility. I have represented here a computer with 2 displays connected. Let's have a minimum of imagination. This large rectangle at the bottom is the central unit of your computer, and on the top right, a screen is connected to it, with some text displayed, the first verses of the famous soliloquy of Hamlet. Now you see on the top left another display connected to the computer. It is supposed to represent a Braille device, which displays a line of text in Braille, usually 30 to 40 characters. Some keys, here with the arrows, allow the users to navigate within the content of the screen. Currently the first line, to be or not to be, is displayed, here, in Braille. When I press on the arrow key, the second line, that is the question, comes. Okay? Let's come back to the first line. Now let's open the central unit to see how it's inside. You may recognize several parts. Here I have represented the hard drive, where all your data is stored. I have skipped a lot of parts that are not interesting for this demonstration, like the motherboard, the CPU, the network card, etc. Here I want to focus on 2 other elements. The main memory, where the application and the data you are currently working with are loaded, and the video card, which is driving the screen. The work of the video card is to transform the information to be displayed into a video signal for the screen. In the main memory there are now 2 pieces of software. The application that you want to work with, let's assume it is a browser here, but it could be any application. So we will call it the application. And the operating system of your computer. It may be Windows, Mac OS or Linux. At the moment the Braille device is not yet connected. Let's imagine we have a file stored in the hard drive which contains our text. When we open it in the application, its content is loaded into the memory in the area of our application. The application creates the layout and sends it to the operating system. Then the operating system will calculate the image to display on the screen and send to the video card a table of numbers representing the colors of each pixel of the screen. And finally, the video signal is produced and our text appears on the screen. Okay, but how does it come to the Braille device? The Braille device needs a special piece of software that is called a screen reader. Screen readers are also able to talk using speech synthesis, but we will only focus on the Braille part. The idea is the same for the speech actually. So the screen reader is also loaded into the memory and will drive the Braille device more or less as the video card drives the screen. To better understand the origin of software accessibility, let's see how first screen readers were functioning back in the 90s, where computers were able to display only text. You might remember these computers with those ugly green characters, or maybe you've seen some in old movies. What was different inside at this time? Well, the screen was only displaying text, so the operating system would directly send text to the video card without bothering about pixels. The video card would contain the characters themselves to display, and the card would produce the video signal from it. At this time, the first Braille devices had just been invented, and the first screen reader would directly read the text in the video card memory and send it to the Braille device. It was as simple as that. But in the 90s appeared graphical screens. This implied a big change in the way a computer works. And finally, software accessibility features started to be needed. As we've seen, now the video card contains only numbers corresponding to colors of each pixel of the screen, so the screen reader cannot read any more useful information there. Several solutions have been tried at this time, but very quickly the community realized that the only efficient way would be to have a backdoor in the operating system, allowing the assistive software to get directly the information from the system. At the beginning, the operating system editors were very reluctant, and it has been a long story that I won't tell here to make them implement that by creating an accessibility layer in the operating system itself. Finally, today all major operating systems have an accessibility layer that allows a screen reader or any other type of assistive technology to ask the information it needs. Here's the text of the first line. This also had an implication for the application developers who had to implement an accessibility interface, so that the application can send to the operating system what it needs to fit the assistive technology. Now, with this accessibility framework implemented in the operating system and in the application, the text can be displayed on the Braille device. So it seems we have an accessible computer, and the accessibility looks like a very technical thing which was solved by the developers of operating system and of the applications. Then why would authors of documents have anything to do to contribute to accessibility? Actually, it is not as simple. Indeed, now we have a computer with a nice graphical screen, so we have also the possibility to put images on the screen. For instance, I want to illustrate this text with an image, a drawing of a skull that usually the actor playing the role of Hamlet is holding in his hands when he says these verses. The image will be stored in a graphical format on the hard drive and linked to the main document. Let's load this document in memory again. The application creates the layout and sends it to the operating system, which again creates an image to put on the screen. Now our document is properly displayed on the screen. Okay, but what should the operating system send to the screen reader? It cannot guess what's on the image. So now you've guessed. It is the author who have to say that. If the author adds an alternative text in the document, here the text is a skull, then the application will be able to get it and send it to the operating system to be transmitted to the assistive technology. Now the text a skull can be displayed in Braille. And of course, if I press the next button, the screen reader will ask what comes next to the operating system, get the text of the first line and display it to the Braille. The alternative for graphical content is one of the things that authors have to provide to contribute to software accessibility, which is easier to illustrate, but a few other things are necessary. Digital content accessibility is only a question of following a set of simple accessibility guidelines. To conclude, we have seen that software accessibility has 3 dimensions corresponding to operating system, to the application, and to content. The operating system must have an accessibility infrastructure, able to exchange information with any assistive technology, and must provide an accessibility interface to application developers. This is very technical, but only developers of operating systems have to do that. Then the application has to implement this accessibility interface to send to the operating system what it needs for feeding assistive technology. This is also technical, easier but still quite technical, but it's implemented by the application developers. And the third level is that users, everyone, should create accessible documents. This is not difficult at all, actually. Everybody can do it. It only requires that users will conform to a few simple guidelines. Thank you.